1, which is linear conduction. So to begin the experiment, the first thing we need to do is we open the water supply. Then open the valve. And check the outlet. Okay. Next, we are going to turn on the main supply and the heater switch. Assalamualaikum and very good morning. And now we are doing a lab for linear heat conduction experiment. So for now we are doing the apparatus Cooper stainless middle section. So the first thing, before we apply this thing into this material, we need to apply the heat shrink compound 340. So how to apply? You just put in this like this, and then sapu rata, and then you just spread it. So it become white. Okay. So it become like this. So you doing both side. So for this I just show a sample for one side. So doing both side, and then that's all from me. Thank you.
Okay, now we will install the copper middle section in the middle of the cylinder.
Bayar atas.
Oi, mau masuk. Right, now push the clip. Yeah.
Thermocouple.
And for the thermocouple, make sure each thermocouple is connected properly according to the number. And don't forget this one, thermocouple from the copper.
Okay.
So after we done setting up the apparatus, then we can proceed to begin the experiment.
So firstly, we turn on the heater and adjust the power to 30 watt. Then we wait for the temperature to stabilize. After the temperature has stabilized, then we can record the data. After that, we increase the temperature to 50 watt. And then we wait for the temperature to stabilize. So then we repeat the same procedure for the 60 watt, 70 watt and 90 watt. That's all from me. Thank you.
So once we are done with the experiment, we will change the middle section with other material. So the other material is brass and stainless steel. And for the other material, repeat the same step. Just the same.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is MOHAMAD bin RAHMAN.
And today me and my group will be presenting the report for lab 1, which is linear conduction. So first of all, we will look into the result we obtained from the experiment. So for this experiment, we use three different material, which is brass, stainless steel, and stainless copper. So the T1 until the T7 is the sensor position from T1. For each material, we test it with three different power input, which is 30 watt, 50 watt, and 90 watt. So in the right side, we can see there is a graph temperature versus distance. As we can see, as the distance increase, the temperature will also decrease. So this is the result for stainless steel media section. So from the graph, you can see that as the distance increase, the temperature will decrease. And the last one is the result for stainless copper media section. The graph also shows that as the distance increase, the temperature will decrease. That's all from me. Thank you.
Hello and Assalamualaikum to everyone. Uh, I'm Amir bin Muhammad Adnan. We explain about the discussion. We calculate the gradient of the chart. What does this gradient represent in the conduction equation? So this graph about the temperature versus distance, that is brass. So the uh, maroon line is about 30 watt, the pink line is 50 watt, and the orange line is 90 watt. So we get, based on the data, we get the 90 watt, that is 90 watt, the orange one get the highest, that is the highest one is 90 degree Celsius, and the second we get the 50 watt. 50 watt become the number 2 highest temperature, that is 60, and the 30 watt, uh, the last one temperature that we got is around 54 Celsius. The temperature versus distance in meter is about the stainless steel. So in this graph, we get the maroon color is 30 watt, the pink color is 50 watt, and the orange color is 90 watt. So the dot is the linear line. So as we can see the linear line, on the graph, orange become increase until 65 Celsius. So uh, the 50 watt become increase also at the 52 Celsius, and the last one is the 30 watt is become 48 Celsius. So basically we can see on the graph that is the higher temperature that we get for stainless steel, around 90 watt is 65. So the second place for 50 watt, and the third place is 30 watt. And that's all from me. Thank you.
Assalamualaikum. My name is HAMYZAN bin Adnan, and I will present about the discussion number 1 and number 2. For question 1, the question required to calculate the gradient and then explain the representation of the gradient in the conduction equation. So this is the graph, and then the gradient is represent the physical term that describe how rapidly and which direction the temperature changes in each area. It also means that the gradient temperature line is the ratio of the temperature difference between 2 points to the distance between these 2 points. For question number 2, the question requires us to calculate the thermal conductivity of the material and then make comparison between the experimental value and the theoretical value. So the thermal conductivity that we obtain for brass is 63.9, for stainless steel is 70.8, and then for copper is 70.14. So from the thermal conductivity value that we have obtained, we have created a table to represent the calculation and the percentage error. So for brass, the percentage error is 48%, for stainless steel 342%, and stainless copper is 80% to 81.82%. So the main cause of the error is the thermal energy may be lost to the surrounding. Next is proper physical contact may not be achieved. Then impurities in material may cause heat flow non-uniformly. And lastly, type and shape of material that may affect the radiation coefficient. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ISHAK bin FUZILAH. I will continue to explain about the discussion of this report. Question number 3 is, what can you observe from the gradient of the chart for each power setting? We observe that the different type of material affect the different temperature, whether it is raise or drop. The second is, the estimate gradient show the decrease because of temperature is decreased with the increase of distance. Number 3 is, as for the heater power setting, we can observe that with the increase of power setting, the more value of gradient decrease from the chart. The more the heater power setting increase, the more the temperature increase from the all of the distance. And lastly is, this may apply to all the material that has been experimented. For question number 4 is, add a best fit line through all the results to define overall thermal gradient. We use the K value that we found from the first procedure for the brass section each side of the middle. We found that T1 for the brass is 326.4 Kelvin, T7 is 302.7 Kelvin. The K value for the brass is 63.49. The area is 2.376 micro. The L value mid is 0.02. We found that R equal to L over K times A. We get 0.132. The R total value is 0.79. The R mid is 0.526, and the lastly is K value for the mid is 16.01 watt per meter Kelvin. For the conclusion is, error occurred due to several factors such as a loss of thermal energy, improper physical contact, and impurities in material. We were able to calculate the thermal conductivity of the material. The heat transfer is better in material which is with higher thermal conductivity. Among the three different materials, copper is the best heat conductor. Lastly is, we conduct the experiment successfully. That's all for me. Thank you.